Thanks for joining our talk, Taming the Distribution Sprawl. A little bit about us and about the company we work for. So I'm Raj. My co-presenter is James. We work as systems engineer in Quantcast. And Quantcast is an online ad tech company that started in 2006. Some numbers to give you guys a sense of scale. So we handle 3.3 million bid requests at peak. And our 99th percentile latency, we try to keep it below 80 milliseconds. A little bit about our infrastructure story. So in 2006, we started with our own data center. 2016, we decided that we wanted to move from our own data center to AWS. 2017, we did a complete lift and shift from our data centers to AWS, and we retired our data centers. And 2018 onwards, we have been continuously optimizing the way we work in AWS. Our infrastructure works in AWS. So when we did the lift and shift, we gave quite a lot of freedom to our services and teams on how they wanted to manage their EC2 instances. Each team was responsible for managing their own AWS instance. They could choose to run whatever distribution they wanted to run. And we gave each engineering group a dedicated AWS account. The one thing that we were pretty strict on was that all the services and infrastructure needed to be managed through Terraform. So things were going fine, but then why push for distro standardization? So we are part of the cloud platform team, and starting 2020, we started seeing some maintenance headaches with the way things were working, mostly due to the wide range of Linux distributions that people had installed on their clusters. So some of the operational headaches we ran into was that we had some distributions with very small, very short support cycles. So that would mean that we would be left with unpatched security systems in our clusters after a year. We also noticed that we had some of our in-house packages would not run on certain distributions because some of the required libraries would be missing. We also had discrepancies in commonly used troubleshooting tools. For example, traceroute on certain distribution would support the TCP option, but on some distribution, they would not have the TCP option available, just the UDP option. Then we also had distribution shipping with different kernel versions, and that would mean that we could not provide our engineers with a standard set of sysctl settings that would make it more performant, our clusters more performant. So in 2020, we started the work of coming up with a proposal of some standardized distributions that would be available on our clusters. So we had some criteria that we wanted to fit. We wanted our recommended distribution to support what our large clusters are already using. And we wanted to stick to a distribution that was RPM based, since most of our package tools come as RPMs. We wanted a distribution that had a long support cycle, specifically up at least 3 years, so that way we did not have to deal with unpatched systems in our cluster. And we wanted a distribution that prioritized stable packages instead of being on the cutting edge. So based on this, our choices came down to Amazon Linux 2, CentOS 7.9, and then we also created hardened images for both this distribution. The idea was to provide a secure baseline environment for our engineers to run. So once we had come up with this recommendation, we had to get our engineers to start migrating to it. And this was in like 2021, which was in the middle of the pandemic. So to start the process, a little bit about the Quantcast culture. We thrive on a bottom approach. Most of our initiatives are engineer-driven, and this has worked well for us. We also wanted our teams to continue delivering features and new products. So for the cloud platform team, that meant that we wanted to achieve significant migration without taking too much of engineering time. So to start the process, we had a dialogue with our engineers. We started a FAQ. We had a tech talk where we addressed any concerns, and we answered questions around like why we picked certain distribution and why not some other distribution. We had also, during this, using our checklist, we had kept our distribution, which was like pretty close to what our large clusters were already using. And we also promised a more streamlined approach, since we would have a standard set of toolkit available, especially during incidents and outages. So this actually convinced quite a lot of engineers, and we started the migration for our journey. And during this part, the first part of that was the discovery process. So for discovery process, like to canary our recommendations and to iron out the bugs in our recommendations, we picked up teams that had already a strong partnership with the platform team. We picked teams which had large clusters to run. So the idea was that if 1 or 2 machines went down, it would not impact the availability to a large extent. We also wanted teams which had an automated and streamlined deployment process, because it would be easier to roll back and roll forward if required. And we preferred services which were mostly stateless for the discovery process. So when we went in with the discovery process, the mindset that we went in with was that we would have some failures and we'll learn from those failures. So as part of that, we would provide the teams with a migration plan, and we would also have a rollback plan alongside the deployment plan. We kept our pull request to be pretty small for this migrations, as small as we could, and we would merge it with the on-call engineer support. And when this deployment would happen, it would be run by someone on the platform team itself. So that way, if there is an incident or if there is a failure, we are there to do a post-mortem to help the teams roll back and also to learn from our mistakes. Once the discovery part was done, we started, and we had ironed out the small bugs that we had. We started asking teams to move into our recommended distribution more aggressively. We started with putting our migration targets into quarterly OKRs that each team would come up with. We offered FAQ, and we offered sample pull requests to the teams to help with the migration path. We also had a dedicated on-call platform engineer available for any migration assistance if required. We also had the idea that some of our critical services will go through 2 or 3 cycles of rollback and roll forward before the migration is completed. And in some cases, there were services which had lost some of the engineers due to organizational changes and didn't have enough engineers to handle the migration. And in those cases, the platform engineers themselves did the migration. So at this point, I'll hand over the presentation to James.
Hi, thanks. So as my colleague Raj had mentioned, there were some anticipated bottlenecks when initially approaching this. Most notably with identification and categorization of hosts across a large variety. When moving to AWS from an on-prem or co-located setup, things moved very fast. As a result of that, some things like standardized tagging and ownership of something that can go through the course of years can be difficult to retroactively revisit and kind of pinpoint. In some cases, the systems that were generally targets for this initiative, they needed to be upgraded. So as a result, it's more likely to find such systems in a state that some builds need to be updated or refreshed or done more frequently. And in some instances, some of these systems, after a more further discovery, might be indicated to be replaced with another system that solves a similar feature set, for instance. So we had some planned solutions naturally. Prioritizing work on large clusters. So instead of focusing on a 4-node auto-scaling group, focus on one that's 200. Leveraging Datadog metrics and dynamic tracking to keep inventory at scale and just get real-time reporting on that. Moving just infrastructure to Kubernetes and containerizing them wherever applicable, rather than using EC2, which naturally has a lot of orchestration benefits as well. And just directly partnering with teams, since it's every system's going to be a bit different. So for deployments on AWS, it is a pretty standard procedure that many practitioners are familiar with, is usage of HashiCorp tools like Packer, Terraform to spin up, as Raj had mentioned, a hardened base of Amazon Linux 2 or CentOS 7.9 that can be built upon. Additionally, Terraform another downstream Packer build would generally leverage this to install some more packages, and then Terraform to spin it all up with user data or Cloud.init script to just install updates or anything is needed, which is quite a common workflow, and it helped quite a bit with just staging, testing changes, and rolling back as we worked with on-call of a given team and kind of initiated changes. But yeah, so doing this at scale can be difficult, as individual contributors. So tools like SourceGraph that allow us to search through the data, search through our whole code base, specifically for infrastructure as code like Terraform, to kind of match service names or any other sort of regex matches to tags and labels for the service to identify it and modify the infrastructure as code where applicable. Was quite useful. Datadog dashboards, Jira, of course, unfortunately. Just kidding. And so going a bit further, so there were some unexpected things that made this a bit more of a challenge than we had anticipated. So this was the beginning of the pandemic. There were organizational changes that left some systems within a more precarious situation and difficult to get priority. Additionally, as a result of that, maintaining focus over more than one quarter on this particular goal, it can be, it just took a lot more time than we anticipated, I guess you could say. So yeah, the general solution we came to, is kind of discussed previously, is initiating changes with commits and pull requests where applicable, rather than just opening a ticket or messaging someone on Slack. It's a pull request is a great way to start that conversation and actually just get the foot in the door with changes that will actually be realized if merged. So unexpected good results from this was there were opportunities to terminate some systems if applicable, or if move to a Kubernetes workflow. It gave a bird's eye view of patterns of configuration management. I did mention Cloud.init and user data, but instances of Salt and Ansible being used as well, and just kind of coalescing those into one standard workflow, or getting close to that point was great. Yeah, and additionally, just wherever possible, rather than just updating Terraform and moving these directly to containerized deployments, was a huge benefit, and saved time with better orchestration and money, and just most yeah. So there were some good outcomes of this, mostly. Instances of applications migrating to Kubernetes. There's improved security measures for the company's systems, most notably. We included agents in our hardened base images that report on CVEs for centralized tracking of them moving forward. We also just increased consistency with our Terraform where applicable, and got more things into a managed Kubernetes platform. And just having an up-to-date distribution. CentOS 7.9 and Amazon Linux 2 were a great stepping stone to moving forward. Right now we're looking at Amazon Linux 2023, which our hosts are currently on, which has a 5-year EOL, or a 2028 experience. So it's quite a good path forward as opposed to before. So some takeaways is. When approaching this, it's important, at least I found it important to kind of manage, there's two needs that you're managing. One is of actually implementing the change, and one is managers who are interested in the progress as it continues, particularly if like a goal like this that can kind of overarch multiple quarters at times. So having like great tracking systems for visualizing this in real time as it changes to be up to date, and additionally taking initiative with individual contributors to make changes and deploy them and follow the correct procedures. Accommodating exceptions is naturally extremely crucial here. Amazon Linux tunes at 7.9 are great, but they don't have everything everyone always needs, like NVIDIA GPU drivers, for instance. Also, just preparing for any like sort of a large migration process. Prepare for hiccups and potentially taking longer than anticipated. It's quite crucial. And yeah, I think that just about wraps everything up. We can open it up for questions if appropriate. Yeah, thanks.